Hi! A delightful day for everyone. I am Case Petito, a member of CHEM CHARLES CLUB, and will be your loss for knowledge and will support your chemical dilemma.
We first begin by recalling what is combined gas law are all about. From the word combined in the slide, it means the PBT, or we could say the pressure, volume, and temperature is having a relationship with one another. It means the PBT is having a relationship with one another, or in short, the three major gas laws are being combined. It is the Boyle's law, Charles' law, and Gay-Lussac laws. We use these three gas laws if ever the tree or the PBT is interchanging due to the certain given problems and situations.
States that the ratio of the product of pressure, volume, and the absolute temperature of a gas is equal to a constant. This is not actually a new law. This only combined into a single relationship, pressure, volume, temperature for gases. This expressed in the following equation. P1V1 over T2 equals P2V2 over T2.
In this table, it presents the summary of the three different gas laws, which is Boyle's law, Charles' law, and Gay-Lussac's law. It will teach us how we derive from getting the combined gas law. In the first column of the table, we can see that all of those were derived from the three combined gas laws. In the second column of the table, it shows the present hold constant, whereas we had to assume that there are really properties that will be constant.
The third and fourth is the action that happened, where there will be elimination. One will be eliminated because it is constant property, while the two properties will going to change. The last column will show you what is the relation that will be held due to the given situation. The relationship will be either Boyle's law, Charles' law, or Gay-Lussac's law. For instance, if the constant is the ratio of moles and the pressure, then we were going to cancel or eliminate in the formula the P1 and P2 from the combined gas laws. So the properties will only be the VT, therefore we will be going to use the formula of Charles' law, which is V1T2 equals V2T1.
However, in this discussion, we are going to focus specifically on Charles' gas law. So what is Charles' gas law? Are you familiar with this? Or do you have any idea? Well, if you don't, let us give you one situation and let us help you with your dilemma.
Charles' law studies to determine the effect of temperature change on volume of gases was first undertaken by Charles in 1787. Charles' law stated that the volume of a given mass of gas is directly proportional to its absolute temperature at constant pressure. Recall that absolute temperature T equals to degrees Celsius plus 273, or T is equals to degree Fahrenheit plus 460. Mathematically, Charles' law may be expressed as V equals to KT, or V over T is equals to K. It may also be written as B1 over T1 is equals to K, and B2 over T2 is equals to K, or T1 over B1 over T1 is equals to B2 over T2, or B1 T2 equals to B2 T1.
Example, a sample of neon gas at 760 torr has a volume of 5.0 liters and a temperature of 17 Celsius. Find the new volume of the gas after the temperature has been increased to 47 Celsius at 760 torr. Initial conditions. T1 equals to 17 Celsius plus 273 equals to 290 K. P1 equals to 5.0 liters. Final conditions. T2 equals to 47 Celsius plus 273 equals to 320 K. V2, question mark.
So the initial conditions, which is the before. Temperature 1 is equals to 17 degrees Celsius and volume 1 is equals to 5.0 liters. And for the final condition, which is the after. Temperature 2 is equals to 47 degrees Celsius and volume 2 is missing. Since the given temperatures are at the Celsius form, we need to convert it to Kelvin because that is the rule. And to convert it, the value is always 1 degree Celsius is equal to 273 Kelvin. And that's why we need to add 273 to the given temperatures beforehand. The required is volume 2 because it is the missing on the problem. The equation is equals to V2 equals V1 times T2 over T1. The solution is substituting the given value on the righteous places, which becomes 5.0 liters times 320 Kelvin divided by 290 Kelvin. You just need to solve this and you will get the answer of 5.5 liters of volume, which indicates that when the temperature increases, the volume must increase.
Conclusion of the experiment. As the boiling water increases its temperature, then the balloon will increase its size and volume. As stated in Charles' law of gases, it says that in a closed system, temperature and volume change proportionally to one another.
If one temperature increases, so does the volume. If the volume increases, so does the temperature, and vice versa.
As stated by Charles' law, as gas increases, the temperature will increase and vice versa. A decrease in the temperature will lead to reduction in volume. In Charles' law, the pressure is constant. Here, in the experiment, we want to demonstrate how the temperature affects the volume of the balloon. The material we use is balloon, cups, hot water, and cold water. Here, we can see that the hot water expands the balloon's volume due to its temperature, while in the other experiment, the balloon did not expand because of the low or the cold temperature of the water. Therefore, we can conclude from the experiment that the volume of a given mass varies directly with the absolute temperature of a gas when pressure is kept constant. The more frequent collision result in a higher pressure. However, if it is adjustable, the volume will increase and the pressure will remain or the same or it fixed. And that's all for the experiment and knowledge for today.
I am Amir.
I am Jad Dial.
I am Joshua Ray de Simocho.
As for your knowledge and support for your chemical dilemma.